Good day, friends, and welcome to another WASE online experience. My name is Philip, your instructor. But before I start for today's program, I'll need you to subscribe for it if you have not already done that. Remember, we need your subscription for the continuation of this program. To do this, just tap the subscribe button below the video. Thank you very much for doing this for us. Let's look at our activity for today. So today, we'll be looking at part 7 of bearings and vectors. And under this part, we'll be looking at the following topics. First, we'll be finding the angle between two vectors. Then second, we'll be looking at the midpoint of a line segment. So first, we'll look at how to find the angle between two vectors. To be able to find the angle between two vectors, we need to know two main things. So first, we need to know about the magnitude of vectors. Then secondly, we need to know about the dot multiplication of two vectors. We have treated magnitude of vectors in the past, so the assumption here is that you know how to do this. So for most of the calculations we'll be doing on magnitude of vectors, we'll just go straight to the point. So please, if you do not know how to do this, I would encourage you to visit our other videos on magnitude of vectors and listen to them. Now let's take the vector A equals to 1, 3. The magnitude of the vector A will be given as. So we have the vector A in between two bars. That is how we denote magnitude of vector A. And this will be given as the square root of all into bracket 1 square plus 3 square, bracket closed. The 1 square would give us 1 and the 3 square would give us 9. So what this means is that we would have square root of all into bracket 1 plus 9, bracket closed. And when you add the items in the bracket, you would get 10. So the magnitude of the vector A will be equals to square root of 10. I believe this was very easy for you to do. Let's look at the dot multiplication of two vectors, or what you also call the dot product of two vectors. So if you have the vectors B and C, the vector B is equals to MU and the vector C is equals to NR. Then the dot product of the two vectors will be denoted by the vector B times the vector C. And here we have used dot to represent the multiplication sign. So this will be given by, so first multiply the two S components at the top, which is M times N. So first do that multiplication, then add this to the two Y components, that is U and R, also be multiplied together. So let me quickly repeat this. If you have the vectors b and c with those components, and you have to find the dot product of the two vectors, all you need to do is to multiply their x components together. In this case, the x component of the two vectors are m for the vector b and n for the vector c. So you multiply those two components together and you write it down. Then you add this to the product of the y component. And here the y component are u and r. So we multiply them also together. So we add it as is being shown on the screen. So it's as simple as that. So let's look at an example. We have the vector b equals to 5, 3 and the vector c equals to 4, 2, and we have to find their dot products. So first, the dot product of bc, this will be equals to first the x components multiplied together, and here the x components are 5 and 4, so we multiply them together. Then our plus sign followed by our y component multiplied together, and here the y components are 3 for the vector b and 2 for the vector c, so we multiply 3 and 2 together. So this would give us the 5 times 4 would be 20, and the 3 times 2 would give us 6. The 20 plus the 6 would give us 26. So the dot product of the two vectors b and c will be equals to 26. Now at this moment we know how to find the dot product of two vectors. We also know how to find the magnitude of a vector. So we are going to use this two information to look for the angle between two vectors. At this moment we are going to find the angle between two vectors. To be able to do this, we would need this formula. This formula states that cos theta is equals to the dot product of the two vectors involved divided by the product of their magnitude. Remember, the theta here is the angle between those two vectors. We already know how to find the dot product of a vector or two vectors, sorry. So all we need to do is to find that. When we are done, we put it into this formula. Then we find the magnitude of the individual vectors, and we also multiply them together and we put them into the formula. It's as simple as that. So let's quickly look at this. So let's say we have the two vectors a and c. The vector a is equals to 2, 4, and the vector c is equals to 1, 3. And we want to determine the angle between these two vectors a and c. So we have to do three main things. First, we would have to find the magnitude of the vector a. When we are done, we'll find the magnitude of the vector c. Then we'll find the dot product of the two vectors a and c. So let's start by looking for the magnitude of the vector a. The magnitude of the vector a will be given by square root all into bracket 2 square plus 4 square bracket closed. This would give us square root into bracket, the 2 square will become 4 plus the 4 square would become 16. And when you solve this, you would get square root of 20. Let's look for the magnitude of the vector c. The magnitude of the vector c will be equals to square root into bracket 1 square plus 3 square, bracket closed. This would give us square root of into bracket 1 plus 9, bracket closed. And when you compute this, you would get square root of 10. We know the magnitude of the vector A and the magnitude of the vector C. Let's find the dot product of the two vectors A and C. So this would give us 2 times 1 plus 4 times 3. Remember, we first multiply the s component of the two vectors, then we added this to the y component of the two vectors being multiplied together. This would also give us 2 plus 12. Remember, the 2 times 1 is 2, plus the 4 times 3 is 12. And the 2 plus the 12 would give us 14. So now we have the magnitude of the vector A to be square root of 20. Then the magnitude of the vector C is square root of 10. Then the dot product of the two vectors A and C is 14. So we are going to use these three information to solve or to find the angle between these two vectors. So we have our information here. The magnitude of the vector A to be 20, that of the vector C to be 10, and the dot product of the two vectors is 14. First, we would state the formula we would use to determine the angle between the two vectors. This formula is cos theta equals to the dot product of the two vectors divided by the product of their magnitude. So that will be given by cos theta equals to the dot product of the vectors A and C divided by magnitude of A times magnitude of C. So at this point, all we will need to do is to substitute our information into this formula. So let's quickly do this. First, the dot product of the two vectors is 14. So let's write 14 as the numerator. So we have the 14 divided by, first, the magnitude of the vector A. So let's write the magnitude of the vector A, which is square root of 20 downwards. That's the denominator. Then we have our multiplication sign, followed by the magnitude of the vector C, which is square root of 10. And when you put this on your calculator, you'd get 0.99. And please remember, I have only rounded this to 2 decimal places. This means that our cos theta will be equals to 0.99. So the theta would be equals to the cos inverse of 0.99. And when you punch cos inverse of 0.99 on the calculator, you would get theta to be equals to 8.13. Now we have been able to find the value of theta, which is the angle between the two vectors. So what it means that the angle between the two vectors would also be equals to 8.13 degrees. Now let's look at some examples. Example 1. In this example, we have the vectors A and B, and the vector A equals to 3, 5, the vector B equals to 5, -3. Our work is to find the angle between these two vectors. So let's do this. So first you find the magnitude of the vector A, then you find the magnitude of the vector B. Afterwards you look for the dot product of the two vectors A and B. Then we substitute our answers in the formula. Then we come up with the angle between the two vectors. That's what we're going to do. So the magnitude of the vector A will be equals to square root all into bracket 3 square plus 5 square, bracket closed. This will be equals to square root all into bracket 9 plus 25, bracket closed. When you solve this, you would get square root of 34. Now let's look for the magnitude of the vector B. This will be equals to square root all into bracket 5 square plus the -3 square, bracket closed. And please, I'll need you to note that we squared the whole of the -3 by putting it into brackets. We did not just square the 3 leaving the negative. We squared everything. So note that it's very important. This would give us square root of into bracket 25 plus 9, bracket closed. And when we point this on the calculator, we would get square root of 34. We now know the magnitude of the two vectors. Let's look for their dot products. The dot product of the two vectors A and B will be equals to 3 times 5 plus 5 times -3. And I believe you know how we arrived at this. We just multiply the two x components of the two vectors. Afterwards, we multiply the y components, then we added them together. So that's how come we got that. This would give us 15 plus -15. Since 3 times 5 would give us 15, and 5 times -3 would give us -15. 15 plus -15 would give us 0. So we know the magnitude of the vector A and that of the vector B. We also know their dot product. So we're going to use this information, the trio information, to solve our problem. So the magnitude of vector A is square root of 34. That of vector B is square root of 34. And their dot product is 0. So let's now state the formula. The formula states that cos theta, the angle between the two vectors, is equals to dot product of the two vectors divided by the product of their magnitude. This would give us cos theta equals to the dot product of the vectors a and b divided by the magnitude of the vector a times the magnitude of the vector b. At this point, we will just substitute our information into the formula. Our dot product of the two vectors is equals to 0. So let's write 0 as the numerator. The magnitude of the vector A is square root of 34. So let's write that down. We will then show our multiplication sign. The magnitude of our vector B is also equals to square root of 34. So we would write that one down. Now when we calculate this on the calculator, we would get 0. What this means is that our cos theta would also be equals to 0. Our theta would also therefore be equals to cos inverse of 0. When you punch cos inverse of 0 on the calculator, you would get 90 degrees. Therefore, our theta, which is the angle between the vectors A and B, is equals to 90 degrees. What this means is that the two vectors are perpendicular to each other. Note that this method can also be used to determine whether two vectors are perpendicular or not. In part 5 of bearings and vectors, we used another method to determine whether two vectors are perpendicular or not. Let's look at example 2. Example 2. We are being asked to find the angle between the two vectors A and B. Vector A is equals to 4, 3, and vector B is equals to 12, 9. Let's look for the magnitude of the vector A. The magnitude of the vector A is equals to square root of into bracket 4 square plus 3 square bracket closed. This will give us square root into bracket 16 plus 9 bracket closed, and that will give us square root of 25. Square root of 25 is 5. Let's find the magnitude of the vector B. This will be given by square root of into bracket 12 square plus 9 square bracket closed. This will give us square root of into bracket 144 plus 81 bracket closed, and that will give us square root of 225, and this would give us 15. Now let's do the dot product of the two vectors A and B. That will be equals to 4 times 12 plus 3 times 9. The 4 times 12 will give us 48, and the 3 times 9 will give us 27. The 48 plus 27 would give us 75. So we have the magnitude of the vector A, we have the magnitude of the vector B, and the dot product of the two vectors. We would use them to find the angle between the two vectors. The magnitude of our vector A was 5, that of our vector B was 15, and the dot product of the two vectors was 75. Let's state our formula. So we have cos theta equals to the dot product of the two vectors divided by the product of their magnitude. So our cos theta will be equals to the dot product of the vectors A and B divided by the magnitude of the vector A times the magnitude of the vector B. So at this point we'll just substitute our numbers into the formula. Our dot product is 75, so let's write it down. That will be divided first by our magnitude of vector A, which is also 5, so let's write that one down. Then our multiplication sign, then the magnitude of the vector B, which is equals to 15. When we point this on the calculator, we would get 1. Our cos theta is therefore equals to 1. Our theta will therefore be equals to cos inverse of 1. When you punch cos inverse of 1 on the calculator, you get theta to be equals to 0. This means that the angle between the vectors A and B is equals to 0. Let's note that when two vectors are parallel, the angle between them is 0. What this means is that the vectors A and B are parallel, and we can use this formula to also determine whether two vectors are parallel or not. Note that when two vectors are parallel and moving in the same directions, the angle between them is 0 degrees. When they are parallel and they are moving in opposite directions, the angle between them is 180 degrees. When they are perpendicular to each other, the angle between them is 90 degrees. So we can use this formula to also determine whether two vectors are parallel or perpendicular to each other. Let's look at example 3. Example 3. So we have to find the angle between the two vectors A and C. The vector A is equals to 0, negative 4, and the vector C is equals to 7, 0. Let's first find the magnitude of the vector A. The magnitude of the vector A is equals to square root all into bracket 0 square plus negative 4 square bracket closed. And please here note that we are squaring the whole of the negative 4, not just 4. This will give us square root all into bracket 0 plus 16 bracket closed, and this will give us 4. Let's look for the magnitude of the vector C. This will be equals to square root all into bracket 7 square plus 0 square bracket closed. That will give us square root all into bracket 49 plus 0 bracket closed. When we solve this, we would get 7. Let's look for the dot product of the two vectors. The dot product of the two vectors A and C would be equals to 0 times 7 plus negative 4 times 0. And I believe you know where this is coming from. That will give us 0 plus 0, which would also give us 0. We know the magnitude of vector A. We also know the magnitude of vector C. Then we know the dot product of the two vectors A and C. So what we will do is to use them to find the angle between the two vectors A and C. The magnitude of vector A is equals to 4. The magnitude of vector C is equals to 7. And the dot product of the two vectors is equals to 0. Let's state our formula. So cos theta is equals to the dot product of the two vectors divided by the product of their magnitude. So our cos theta will be equals to the dot product of the vector A and C divided by the magnitude of A times the magnitude of C. At this point, we would have to substitute our numbers into the formula. Our dot product is 0, so let's write it down. The magnitude of the vector A is 4, so we would write it. Let's write our multiplication sign. Magnitude of the vector C is 7, so let's write it. When you point this on the calculator, you would get 0. What this means is that our cos theta would be equals to 0. Our theta will therefore be equals to cos inverse of 0. When you point this on the calculator, our theta will be equals to 90 degrees. So what this means is that the angle between the two vectors A and C is equals to 90 degrees, which also means that the two vectors are perpendicular to each other. I believe you enjoyed this. Well, let's move on to the midpoint of a line segment. Midpoint of line segment. Now let's draw the line segment AB. So we have the line segment AB with the following points. The coordinate of the point A are x, m, and the coordinate of the point B are y, n. Now let's indicate the point T, which divides the line segment into two equal parts. Because the point T divides the line segment into two equal parts, it is called the midpoint of the line segment. So the midpoint of a line segment is the point that divides a line segment into two equal halves or two equal parts. Now we have learned about position vectors. If we are to write the point A as a position vector, it will be written as vector OA, and its component would also be written as the vector XM. The position vector of the point B would also be written as vector OB, and its component would also be written as the vector YN. Also, the position vector of the point T, which is the midpoint, can be written as the vector OT. We do not know the component of the position vector OT, so we are going to look for it. Now I'll need you to note that from this diagram, it is very possible for us to prove and determine the component of the position vector OT. I am, however, not going to do this. But I'm going to just tell you how to find the midpoint of a line segment whenever the 2 points at the ends of the line segment are given. Like in this case, we know the 2 points A and B at the end of the line segment AB. So once we know those 2 points and we can get the position vectors from those points, we can use those position vectors to determine the component of the point OT. To be able to do this, we would use a formula. The formula states that the position vector of our midpoint OT would be equals to the half of, then all into bracket, the position vector of the point A, which is OA, plus the position vector of the point B, which is OB. So let's quickly go through this formula. If you have the line segment AB with the point A and B at the end of the line segment, and you have the point T, and the point T is the midpoint of this line segment, and you are asked to find the position vector of the midpoint, that's the OT of this line segment. All you need to do is to convert the first point at the end, in this case the point A, to its position vector. Then you convert the point B to its position vector. Add the two position vectors together. Whatever you get, just multiply that value by half. In other words, multiply that vector by the scalar half. And that's how you do this. So we are going to solve series of examples, and by the time we are done, you would understand this concept very well. So in this case, our position vector OT will be equals to half of all into bracket vector OA, which is equals to XM, plus vector OB, which is equals to YN. This will be equals to half of the two vectors in the red bracket added together. Note that in the red bracket, the two vectors XM and YN are being added together. So that's what happened. The two were added together. And I believe you know the rules we would need to follow when we are adding two vectors. So we follow that same rule. That's how come we arrived at that. Now let's assume that the vectors OA and OB are, for OA 5, 4, and for OB 3, 8. Then for us to find the vector OT, all we need to do is to substitute the vectors 5, 4 and 3, 8 into the formula we just created. So when we do this, we would get half of the vector OA, which is 5, 4, plus the vector OB, which is 3, 8. So that would give us half of the two X components added together and the two Y components added together. So we have 5 plus 3 and 4 plus 8, half of that vector. This would give us half of the vector 8, 12. So at this point the half would multiply 8, then afterwards it will multiply the number 12. When we do this, we would get the vector for 6. Let's look at some examples. Example 1. So in this example, we have been given the point C to be equals to 2, 7, and the point D to be equals to 4, 3. And we have been asked to find K, the midpoint of the line segment CD. So first we'll write the point C as a position vector, and that would give us the vector OC equals to 2, 7. We would convert the point D to its position vector OD, which is 4, 3. If the point K is the midpoint of the line segment CD, then the position vector OK of the line segment CD would be given as vector OK is equals to half of all into bracket vector OC plus vector OD. So at this point we have been able to come up with the formula to determine the vector OK. So all we need to do is to substitute the values of the position vectors into this formula so we can arrive at the answer for the vector OK. So let's quickly do this. So this would give us vector OK equals to half of bracket, then we have our vector OC equals to 2, 7 plus our vector OD, which is equals to 4, 3. So we will be adding the vectors 2, 7 and 4, 3 together, and when we do this we would get vector OK to be equals to half of the vector 6, 10. Remember that we got the vector 6, 10 by adding those two vectors. So 2 plus 4 would give us 6, and the 7 plus the 3 would give us 10. So that's how come we arrive at the vector 6, 10. So we now have the scalar half multiplying the vector 6, 10, and when we do this we would get the vector 3, 5. So the position vector OK is equals to 3, 5. But I'll need us to remember that the question did not ask us to find the position vector OK, but then it asks us to find the point K. So what it means is that we have to convert this position vector back into the point K. So we would have to write it in coordinate form. So let's quickly do this. So when we do this, we would get our point K to be equals to 3, 5. I hope that was very easy. Let's look at example 2. Example 2. For this example, you've been given the point C to be 2, 7, the point D to be 4, 9, and the point E to be 3, 1. A drawing has been given to us which shows where these points can be located. Then we are asked to find the position vector OM, which is the midpoint of the line segment CD. Finally, we are asked to find the vector ME. So first, let's write all the points given to us in their position vector form. The point C has the position vector OC, which is equals to 2, 7. The position vector of the point D is OD, and it is equals to 4, 9. And the position vector of the point E would be the vector OE, and it is equals to 3, 1. So let's do the first part of the exercise. Let's find the vector OM, which is the midpoint of the line segment CD. Now, if the vector OM is the midpoint of the line segment CD, then it will be equals to half of our bracket, the vector OC, which is the position vector of the point C, plus the vector OD, which is also the position vector of the point D. Then we have our bracket closed. Since we know the position vectors, let's just substitute them into our formula. So that would give us our vector OM equals to half of bracket, then our vector OC, which is 2, 7, plus our vector OD, which is 4, 9. Then we close our bracket. So first we would have to solve what is in the bracket. The vector 2, 7 plus the vector 4, 9. When we do this, we would get 6, 16. So what this means is that our vector OM will be equals to half of the vector 6, 16. Half of the vector 6, 16 will give us the vector 3, 8. So we have been able to do the first part of the question, which is for us to find the midpoint of the line segment CD, and that is 3, 8. So the vector OM is 3, 8. Let's move on to the second part of the question, which wants us to find the vector ME. In this second part of the question, we'll be using our knowledge in vector resolution to do this. So if we want to find the vector ME, then we have to resolve it into its component position vectors. I believe you remember this. When you resolve the vector ME, you would get the vector OE. We would have to then bring our subtraction sign. This will be followed by the vector OM. So at this point we have the vector ME to be equals to the vector OE minus the vector OM. So all we need to do is to substitute this equation with the vectors given to us from the question to arrive at the vector ME. So our vector ME will be equals to the vector OE, which is 3, 1. Then our minus sign, we would then bring our vector OM, which is 3, 8. So our vector ME is equals to the vector 3, 1 minus the vector 3, 8. When you solve for this, you would get the vector ME to be equals to 0, negative 7. So we've been able to find the vector OM, and we've also been able to find the vector ME. I hope you enjoyed this. Let's move on to example 3. Example 3. In this example, we have been given an isosceles triangle, and the isosceles triangle has the vertices A, B, and C. Now, a perpendicular line has been drawn from the apex of this triangle to meet the base CB at the point H. I'll need us to note that the point H is dividing the base CB into two equal parts because this shape is an isosceles triangle. So what it means is that the point H is the midpoint of the line segment CB. The question has also been able to give us the point A to be 6, 7, and the point C to be 6, 2. It then went ahead to give us the vector AB to be 8, 3. We are now being asked to find three main things. First, the position vector OB, then the position vector OH, finally the vector HB. Before we start with the solution, let's convert the point A to its position vector OA. When we do this, we would get the position vector OA to be equals to 6, 7. Let's also convert the point C to its position vector OC. And when we do this, we would get the position vector OC to be equals to 6, 2. Now let's write the vector AB to be equals to 8, 3. We will now solve the first part of the question, which wants us to find the position vector OB. To find the position vector OB, let's use the following relation. So the relation vector AB is equals to the vector OB minus the vector OA. Now the reason why we selected this relation is because from the question we know what the vector AB is. In fact, the vector AB is the vector 8, 3. We also know what the vector or the position vector OA is. That is the vector 6, 7. So you see, because we know these two vectors, we can put them into the equation and we can find what the vector OB is. So we are selecting this relation because we know two of the vectors. So we can find the third one, which is the vector OB. So since we are looking for the vector OB or the position vector OB, let's make it the subject. So that's what we are going to do next. Then afterwards we'll substitute our information into the new equation. Then we'll come up with the vector OB. When we do this, the vector OB will be equals to the vector AB plus the position vector OA. So now let's substitute our information into this equation. Our position vector OB will be equals to the vector AB, which is 8, 3, plus our position vector OA, which is 6, 7. So our position vector OB will be equals to 8 plus 6, and that is the x component, and on the y component you would have 3 plus 7. When you solve for this, our vector B will be equals to 14, 10. Let's do the second part of the question. In this part, we are being asked to find the position vector OH. From the diagram, we know that the position vector OH is the midpoint of the line segment CB. So what this means is that we have to use this formula, which states that the position vector OH equals to half of bracket position vector OC plus the position vector OB bracket closed. So that's the formula we would have to use. From the question given to us, we know the position vector OC to be equals to 6, 2. And also from our calculation, we know the position vector OB to be equals to 14, 10. So all we need to do is to substitute these position vectors into our formula. So let's quickly do this. So our position vector OH will be equals to half of bracket, then the position vector OC, which is 6, 2, plus the position vector OB, which is 14, 10, our bracket closed. This would then give us the position vector equals to half of the vector 20, 12. Remember that the two vectors in the red bracket were added together to get the 20, 12. When you calculate half of the vector 20, 12, you would get the vector 10, 6. Therefore, the position vector OH is equals to the vector 10, 6. Now let's look at the third part of the question. And here we are supposed to find the vector HB. So since this is a fresh page, the information given to us from the question are here, and the ones we calculated by ourselves are also here. We would need them to do our calculations for the vector HB. So first, let's resolve the vector HB into its component vectors. When we do this, the vector HB will be equals to the vector OB minus the vector OH. And I believe you know how we arrived at this formula. So at this point, we are set to substitute our position vectors into the equation so we can solve for the vector HB. So our vector HB is equals to the vector OB, which is 14, 10, minus the vector OH, which is 10, 6. When you solve for this, the vector HB would be equals to 4, 4. So we have been able to find the vector HB, and I believe you enjoyed this. Well, friends, this brings us to the end of part 7 of bearings and vectors. In our next meeting, we'll be looking at the part 8 of bearings and vectors. And in this part, we'll be looking at the following. 1. The position vector dividing a line into a given ratio. Then 2. The vector in relation to the parallelogram. Well, thank you very much for staying with us, and stay safe. And please, if you've not subscribed for our channel, kindly do so. We need your subscription for the survival of this program. Stay blessed.